Droplet microscope. By looking through a single water droplet placed on a glass surface, one can observe that the droplet acts as an imaging system. Investigate the magnification and resolution of such a lens. So essentially, on a glass table, the water droplets, right? The water droplets here. Um, I was just too lazy to take a video of a water droplet on a table, but essentially they are acting as a convex lens. They're acting as a convex lens, right? And this is the other weird lens called the concave lens. And essentially, what I'm going to be doing today is I'm going to be explaining this convex lens and how it magnifies. And if I feel like, I'll also probably mention the concave lens.
So yeah, this is how a convex lens can be imagined as. It's a triangular prism, a rectangular slab, and another triangular prism, and they're all made of glass. And the convex lens essentially converges all the light rays to a point. Converging means that it brings all the light rays closer together. So this happens because of a phenomenon called refraction, which is the same phenomenon you see when you dip something in water. It looks a bit bent and it looks a bit shorter. And this happens because and refraction is basically light bending when it passes from one medium to another medium. So this is air, this is glass, this is air. So when a light ray passes from air, which is a optically rarer medium, and it passes into glass, which is an optically denser medium, it will bend towards the normal, which is a perpendicular drawn on the medium, and so it bends like this. And this the opposite happens when it goes from an optically denser medium to an optically rarer medium. It will bend away from the normal, and this happens in the second triangular prism as well. But we don't see this in the rectangular slab because according to the laws of refraction, if a light ray passes along the normal, along so we can see that there's a perpendicular here. It's like the light ray is perpendicular to the medium, so it's along the normal. So if it passes along the normal, it will pass undeviated through the medium, and it pass undeviated through the medium, which means that it will not bend through the medium. It will just go straight through the medium. So this is how a convex lens works. This is how a convex lens essentially converges all the light rays. We now to understand why exactly the magnifying drop, the droplet magnifies the image. So or whatever's on the glass surface. So what happens? So to understand that, first we need to understand the two main parts of a convex lens, which are the two focal points, or the foci, or the foci, however you pronounce that. I'm not sure, but so the first focal point is a point f1, right? F1 here, pencil didn't come. Of one on the principal axis, which is this line that goes to the optical center, O, which is basically the center of the lens. And it's so f1 is the point on the principal axis of the lens such that the rays of light coming from it after a refraction through the lens become parallel to the principal axis of the lens. So they're coming from f1, and then they become parallel to the principal axis. That is what f1 is. And then this small f1 is basically the focal length, and f2 is the opposite of f1. And so basically the second focal length is a point f2 on the principal axis such of the lens, such that the rays of light incident, meaning they're coming onto the lens parallel to the principal axis after refraction from the lens, pass through it. So if there are parallel rays of light going through the lens, they will refract and come to the second focal point, and this has a small f2 which is equal to the small f1. So both the foci are located at the same distance on either side of the lens. So now that we understand that, we can understand how the convex lens or the water droplets acts as a magnifier. This is the same application that is seen in a magnifying glass. So the object will be placed. So let's say we're trying to see or we're trying to read something in the newspaper, but the print is too small. So we can use a magnifying glass, and essentially the print will be located between the first focal point uh, and the lens itself. And this AB essentially represents the object. This so, and then from B we can draw two rays here, and from what we've seen in these diagrams, this first ray will pass parallel to the principal axis, and then after refracting from the lens, it will pass through f2, and then the second ray, if a ray passes directly through the optical center, that is the center of the lens, it will pass undeviated. Okay, so it appears to be deviating towards it. Both the rays appear to be deviating away from each other towards infinity, right? But if we trace these back, it forms a virtual image, meaning it doesn't really exist, but we can see it. A virtual image which is way bigger than the actual object. So that means that if there is this letter A on the paper, it will it will magnify this A. Let's say these are the rays, right? And now they are getting refracted. So and now if you trace these back, sorry for the terrible drawing, but if you trace these back, it forms a bigger A. So this is essentially why the water droplet acts as a convex lens on the glass surface and magnifies the whatever's beneath the water droplet. So yeah.